Welcome to Chapter 1, Lesson 8, Roots. Our learning target or objective for this lesson is to compute the numbers written in scientific notation, and that is not correct. We are going to cross that out. I need you to write our objective. We're going to find square roots and cube roots. That's our lesson. All right, we do have some vocabulary words for this lesson. Our first one is square root. One of a number's two equal factors. So a number times itself would be the square root of a number. Our next one, perfect square. Squares of integers. As we'll go through our examples, we'll show some perfect squares. The radical sign, used to indicate the principal square root. Right there's the sign, or sometimes you'll see it all the way across like that, square root. Cube root, one of a number's three equal factors. That's a number times itself three times. As we'll get into some examples of those as well. And our last one, a perfect cube, the cubes of integers. And we'll identify perfect cubes as well. Always, you may pause the video, write them down, and then continue when needed. Okay, our square root. Key concept, words, the square root of a number is one of its two equal factors. And it's shown by if x squared equals y, then x is the square root of y. Examples, we see 5 squared equals 25, so 5 is a square root of 25. Let's dig into some examples. Find each square root of 64. What number times itself would get us 64? And that would be 8. 8 times 8 is 64. That would be a perfect square. Also, you should know that the answer should be plus or minus 8, because a positive 8 times a positive 8 gets us 64, but also a negative 8 times a negative 8 also gets us 64. Keep that in mind. On square roots, answers could be plus or minus, as well as cubed. Now we have the square root plus or minus of 1.21. So let's just get rid of the decimal for a second. 121. Is there any number times itself that would get us 121? And that would be 10 times 10 is 100. 11 times 11 is 121. But the answer is not 11. We have a decimal, 1.1, and it is also plus and minus. Plus and minus 1.1. We'll look at the calculator and show you how to find the square root is there, but also it's good to know, considering standard state tests, you need to do some stuff without a calculator. So we'll be doing stuff without a calculator in class 2 to get you prepared for that. Now the next one, we have a negative 25 over 36. Okay, we're going to see it written like this. And the negatives on the outside of the square root. That means if negatives on the outside of the square root, that means our answer is going to start off being negative. You cannot have a negative underneath the square root sign, but you can have it on the outside. So now we're just going to take the square root of 25. What number times itself gives us 25? That would be 5. Keep the fraction over. What gets us 36? 6. So our answer is negative 5/6. And the last one, we have t squared equals 169. We are solving for t by itself, so we have to get rid of this 2. So in order to get rid of the 2, you have to do the opposite. That's squaring. The opposite of squaring is taking the square root. So what will we do? We have t squared equals 169. What we're going to do is take the square root of both sides. Square root of this, when it's squared, they cancel each other out. That just leaves us our t. Now we have the square root of 169 times itself is 169. 12 times 12 is 144. 13 times 13 is 169. The answer is 13, and it would be plus or minus. Okay, as always, you may stop the video, go back, go over. If you have any questions, please write them down, as we can go over them in class. Now we're going to get to our last page, and our last key concept is the cube root. A cube root of a number is one of its 3 equal factors. So if the x to the 3rd power equals y, then x is a cube root of y. 5 to the 3rd equals 125. So 5 is the cube root of 125. Now we're going to find the cube root. So all you are is looking for a number times itself 3 times to see if it's a perfect cube. So the cube root of 125 is in our example. 5 times 5 equals 25. See, there's 1, 2 5s. Now let's multiply 5 again. And that gets us 125. And that's our 3rd 5. So the cube root of 125 is 5. Remember to count this first 5. Sometimes students forget to count this first 5 and then they'll multiply this by 5 again. And that's not correct. 5 times 5, that's 1 and 2 right there. So that gets you 2 out of the way. Keep that in mind. Now we have the cube root of negative 27. Now we have a negative underneath there, but it's the cube root. When it's the cube root, a negative times a negative is a positive, but a positive times a negative can get us a negative. So you can have a negative inside the cube root. Okay, so what number? Let's think about it. 2 times 2 is 4. Times 2 is 8. So it's not 2. Let's go 3 times 3. 3 times 3 equals 9. There's 1. There's 2. 9 times 3. Whoopsie. That's our 3rd one. Equals 27. That's a negative, so we're going to have a negative 3. So our cube root of negative 27 is negative 3. And let's take a peek at our real world example. Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. Solve the equation 8 equals s to the 3rd to find the side length of s. So let's write it this way. S to the 3rd equals 8. We're trying to find s. We can underline what we're trying to find in the question. S, so we need s by itself. So we have to get rid of this. So just like square root, to get rid of that, we do the opposite, which is cube root. You're going to cube root both sides, because you have to, when you do one side of the equation, you have to do to the other. So these cube roots will cancel out each other. That leaves us our s. Now we're looking for the cube root of 8. Well, times itself 3 times gets us 8. 2 times 2 is 4. 2 times 2 is 4. That's 1. That's 2 2s. That's 8. That's our 3. It is 2. 8 cubed. Always remember, label your answers. Again, any questions, please review the video, write them down, and bring them into class.